Hello everybody and welcome to today's webinar. I am joined today by Paul Gerard of Gerard Consulting UK, and he is going to be talking to you about will robots replace testers? Paul is a regular speaker at EuroSTAR, so much so that he's part of an exclusive group of individuals who've happened to attend over 20 EuroSTAR conferences. He has won the Best Paper Award for his paper on client-server performance testing at the EuroSTAR Conference 2005, and he's also won the EuroSTAR Testing Excellence Award in 2010. And more recently, he was Programme Chair for the EuroSTAR Conference 2014, which took place in Dublin. So we're delighted that Paul has come along today to do this webinar. If you have any questions for him, please type them into the questions field there on the control panel, and we'll get your questions at the very end of the webinar. So that's enough from me. Let me hand you over to today's presenter, Paul. Hello, Paul.
Hi, Dara. Thank you very much. And let's hope you see my screen now. Is that okay? You've got me?
That's right. That's perfect.
Great stuff. Okay. So thanks for that. So I want to talk about testing, robots, artificial intelligence, the whole gamut of topics that seem to be making the headlines, and really explore a few issues that I think are of interest to us all in the testing community. So let me just sort of crack on and just summarize what I want to talk about. I mean, the impact and influence of tools and bots on testing is increasing. I mean, I say that because there are almost every few days, every week at least, there's a new news story basically describing how robots are going to take over the planet, if not all our jobs. And the numbers of jobs and number of people affected varies, and I'll explore that a little bit. But what I want to do is to look at the, if you like, the direction of travel for tools and bots and the advances that are being made out there, and just use one example to illustrate the tremendous capability of these things. And really what I want to look at more closely is like, well, will the way we test be transformed? Are we going to have to change the way we do business? Are we going to be replaced? Are we going to be undergoing a traumatic change? Or is there a kind of a level of support, a degree of support that tools and automation can provide to testers that we have to just assimilate and work with them rather than be replaced by them? So these are kind of the questions I want to explore in the next half hour or so. So you've almost certainly seen the stories that are out there about bots taking over the world. And it's quite clear that many jobs in the next, let's say, 20 years, the next generation, many jobs will be replaced and disappear as career choices, as occupations. And this is quite clear. What is kind of not clear is to what degree we will all be affected. And there are hints that actually it's not the, if you like, manual laborers who are affected, which is what happened with the Industrial Revolution, more or less. It's more the middle class, professional types who are under threat by a lot of the capabilities of these technologies. Now, there's some talk of testers being replaced by bots and tools too, of course. And I've seen every response from impossible, no way, never happen, oh, I'm worried. I don't want to dismiss it. And I have to say I'm not so sure a response of impossible is a sensible response anymore. So I want to explore what tools possibly can do for us. And I want to sort of explore it in a way that you might not have seen. And I want to make some suggestions also as to how possibly we'll have to work with bots, but that's for a little bit later. Now, I think robots won't replace testers for some time, and some time could be a few years or 10 or 20. I mean, there's no real way of knowing. But what I want to suggest is that the tools of the next generation, coming over the next 3 to 5 years, I think they have to start focusing on the support of testers in their exploration, thinking, recording, reporting. I think these are the kind of capabilities that we'll need from tools, and I think that will be the next logical step of the tools industry. Now, the destination might be intelligent robot testers, which basically do everything, replace people. That may be, but I think that's some way off. So I'm kind of anticipating a conclusion I'll make a bit later. But the next steps, I don't think actually require very sophisticated artificial intelligence or deeper machine learning. What's going to happen, I think, is our goals with tools will change and evolve over time. And these different goals will force a change of thinking in the testing community, as it also forces a change of thinking in the tools and automation culture, if you like. So next gen tools won't use artificial intelligence, machine learning. I think what they'll do is they'll pave the way. So I think the next step in tools is a step towards robots that do a lot more testing than they are capable of right now. As an aside, you might already know, and I've said publicly a few times over the last year or so, as a little bit of research, I'm actually building some technology to support some of the ideas I'm going to describe in the next 20-30 minutes or so. I'll use machine learning as a shorthand for what computers do regarding artificial intelligence, deep learning, that kind of thing. Now, all this kind of thinking I've been doing for the past year and a half maybe was kind of came to a head when I saw the news that in March last year, a computer beat the best human player of Go for the first time. And whether you're an expert or completely ignorant of how Go works as a game, it's kind of like chess, and it's kind of the ultimate strategy game, if you like, in that it's much more sophisticated than chess, although chess is pretty remarkable to start with. What Google's AlphaGo program did is it beat a chap called Lee Sedol, who was the greatest living player. No one expected this. People thought we were still 10 or 20 years away from a machine beating a human player at Go. And I'll explain why this is such a surprise. The rules of Go are remarkably simple. There's a board with a grid of 19 by 19 intersections on a grid. And there are only two rules of how you place black or white stones, as they're called, onto that grid. Rule 1, the rule of liberty. Rule 2, the co-rule. That's it. There are no other rules in effect. The winner is the player who basically commands the most real estate on the board at the end of the game. But all other information about the game, given those two rules, is heuristic. There are no rules. All the strategies, ways of playing, decisions, choices, these are all learned through experience of play. Now, what's fascinating to me is that in chess, which is a hugely sophisticated game, you might think, it has 10 to 120th possible moves. That's 1 and 120 zeros. That's the number of combinations and permutations of moves. With Go, the number of permutations, possible moves, is 10 to the 761. It's 10 with 600 zeros after it, times as complex as chess can be. So this is a quite different level of complexity that we've ever seen. Now, we know from for a long time that given that the number of permutations in a Go game is far more than the number of atoms in the universe, there's no possibility of a computer ever learning the game to completion. It's just not like drafts, for example, which has been computed to the ultimate. So humans playing this, they have no chance of outthinking a computer in terms of the combinations, but neither has a computer any chance of outthinking what can be done in a game. So humans recognize patterns and play by intuition and imagination. And the view now is that perhaps AlphaGo, as an example, is actually simulating human intuition and imagination. So I want to draw a parallel between Go and testing. I think, like Go, testing is simple in theory, but is highly complex in practice. And by the same argument that Go may have been computerized, could testing at some point in the future be computerized in the same way? Now, I'm not going to answer that question, but I think this was the challenge to me about a year ago. And I thought, well, you know, is this a really worthwhile thing to look into in more detail? So that got me started. And then I just want to reference some research that's been done separately. And whenever anyone puts a slide up that says a recent study, ... I get very suspicious, I have to say. So take this with a pinch of salt. This paper I'm referencing is an academic paper, needless to say. But what it was saying in principle that in the case of 702 occupations, a huge number of occupations, it looked at how likely those occupations were under threat of computerization, of replacement by computers or bots, whatever. And so it ranks these 702 occupations in order of their probability of computerization. So telemarketers, you know, the junk calls, if you like, from people at the moment is now being steadily replaced by robots. And certainly personally, I get calls, cold calls to my home number, which are robots, and you can identify them very quickly. But this is the way it's going. Telemarketing is going to be done by robots. At the other extreme, you've got the most human kind of activities. Recreational therapists, very unlikely to be replaced. Interestingly, computer programmers came out 48% likely. Now, wait a minute. If programmers have a near 50-50 chance of being replaced by bots, surely we should think seriously about how this could happen to testers. Certainly, there are people out there who actually believe that computer programming, possibly testing, as an allied occupation, are under threat. So we should look at this more seriously. Now, just to derive some of the stats from the paper, I've taken all the occupations that had some bearing on what we do as testers, mostly computer and systems people. You can see the ranking, computer and information research scientists, very unlikely to be computerized. Network computer systems administrators, still quite unlikely. But when we get to developers, network architects, and programmers, you can see 48% chance. Computer operators, nearly an 80% chance. Now, the last occupation at the bottom, you can see inspectors, testers, sorters, samplers, weighers. This is not to do with programming or software testing so much as inspecting raw materials or finished goods in a factory. So these certainly are going to be replaced by computers if they haven't already. But by the same token, we have this challenge of testing only mentioned in that one occupation of 700. So I have this fear that people will associate what we do with the sort of thing that weighing machines actually do. Let's not dwell on that for too long. Now, just to take the kind of rather skeptical or cynical view of all this, the robots are coming meme implies that it's machine learning that's driving all this. And I have to say, I think much of it is hype, and it's the industry trying to sell the next big thing to business. And you know, we've gone through these kind of so-called revolutions many times over the years. And the promise of AI has been the promise of AI for as long as I can remember, maybe 40, 50 years, with you know, Dan Dare comics in the 50s, I think, starting at that early. So there's nothing new with this. And also, some of the occupations that they say will be taken over by robots are actually, well, surely they've been taken over by robots already. Weighing machines and things that validate whether a packet of biscuit is sealed, these are done by robots, you know, already. And there's no need for machine learning in these kind of applications. What has changed is that the data that is collected might be assimilated, analyzed in more sophisticated ways, of course. The human interaction in these occupations isn't sophisticated. So clearly there are things that can be mechanized and automated by bots. So with that kind of context, I want to sort of make a statement here and imply that the test automation that we have today really relates to the mechanization of test execution, test running. So I want to suggest that test automation as we currently know it primarily is to do with mechanics of testing. I want to call them mechanical tools. What we really need from our tools industry are thinking tools. Okay, and this is the case I want to make, and this is where I think the future lies for the tools industry, to be honest. So there's been quite a few comments and debates about whether test automation is a term that misleads and should be banned from our vocabulary. And I don't disagree with the fact that it does mislead. I don't think we'll ever be able to ban it. Let's just understand what it actually represents. Now, what I want to suggest that although the label is bad, I think the scope of test automation is kind of easy to specify. So if you're familiar with the new model of testing that I created a couple of years ago towards the bottom, I would say that test automation relates very much to what I would call applying, the application of a test. Let's not get too drawn into whether test management and test recording is test automation, but test automation focused on executing tests, making comparisons, reporting outcomes. I think that's called applying. That is what I see as test automation. So let's just say test automation covers that aspect of our job as testers. Test automation and test running tools, test execution tools, if you like, they've been around, since the 1970s, probably earlier. My guess is the second program ever written was a tool to run the first program and test it. By the by, the tools in this category include things that do a broader set of activities, but are focused on implementing, applying tests. So the creation of management of environments and data and all the virtualized setting up that we have nowadays, test harnesses, drivers, simulators, mocking, setup, tear down, clear up. These are all activities that that exist in order to allow you to run tests. Now, these tasks have always been part of the test execution process, I would argue. And over the course of the 30 years or so I've been in the industry, of course, the tools are incredibly sophisticated compared with what they were in the 80s. But they don't perform any function that would scare anyone in the 1980s. They do exactly the same job, but just on different platforms. We're not testing mainframes now so much. We're testing mobile apps and things in the cloud. But the mechanics of what these tools do are largely the same. The principles behind these things are largely what were happening 30 years ago. All of these tasks could be done manually and at least in principle. What I want to suggest is what we need is, if you think back to the new model, applying is one of 10 testing activities. It's not 10% of the work, but it's 10% of the thinking. So what we do not have in good measure are tools that support the other 9 activities. They're not well supported because they require some level of thinking and skills that tools simply don't have. Checking, if you care to use that term, is possible when the system and its purpose are well understood. So applying, of course, these might well be checks. I mean, I'm happy to call them checks. We can't create a check without having a very clear understanding of the requirement, how a system is meant to behave, how a system actually operates before we can create a procedure to run a check. So test automation tools are simple in that they are robots that simply replicate or simulate and execute program code that we create as testers to drive a system on the test. In principle, they are simple robots. They are simple compared with the rest of the test process, and that's my kind of précis, if you like. My understanding of how I run a test is based on a lot of earlier work, exploration, modeling, thinking, and so on. If you think about what requirements for tools that support the other 9 activities in the new model actually would look like, let's look at the tasks that you have to support. So there are things like discussing and debating requirements with people, creating predictive models, Now, it's not a case of just capturing a model. It's like you have to imagine the model. The system is too complex to map in all its intricacies, whatever. So we have to create mental models, maybe models that we capture as a document. But creating that model is an intellectual task that robots cannot do yet. We have to think about knowledge gaps, ambiguity in language, gaps, contradictions. All these things are things that people can do probably much better because we're working with narrative text, with natural language. We have to create models across all manner of aspects of the system under test. Models of usage, hazards, risks, modes of failure, extreme, erroneous behavior, and so on. We have to decide when the model we are using is adequate or not adequate for purpose. We have to decide what to do when we run a test. Do we run another test? Do we abandon the project altogether, or anything in between? All these problems, all these tasks that I've set out there, and many more, are human. You could actually call them wicked problems because they are very uncertain. They have a very uncertain basis. There is fallibility in our understanding at every level. So tools that support that kind of thinking do not exist because these are wicked problems to be solved. So I want to summarize that tools must focus on the what, let's say, rather than the how. So just to step back on what testing is, I use this definition when it suits me mostly. Testing is an information, intelligence, or evidence gathering activity performed on behalf of other people, testing stakeholders, to support their decision making. We test on behalf of developers to help them find problems and resolve things. We test on behalf of end users. We test on behalf of project managers. These are all our testing stakeholders. When we are a developer, we test on our own behalf, but the principles do not change. The question is, can we create tools to support tester thinking and capture that thinking? I think the best we can do for now is not to do the thinking, but maybe we can make progress on capturing that thinking. So perhaps the best we can do is to support the thinking and collaboration, perhaps look after the paperwork, and integrate with the test automation. The easy part, as I say. I know the tool vendors will probably be pulling their hair out right now, but I think the tool vendors have taken the low-hanging fruit, if you like. Now, in order to think about this a little bit more carefully, I want to look at what I mean by tool capability for a moment. And there are several dimensions we could look at to say, well, you know, where are we on this journey from today to these all singing, all dancing, all thinking tools? Let's look at two dimensions. I want to look at these two in separation. So information capture, note-taking, modeling capability. I'm going to call that the ability to capture knowledge. The second dimension relates more to, if you like, knowledge acquisition, the thinking, asking good questions. I'll call that the ability to investigate. So here we go. Now to do my little piece of marketing, I'm going to create a 4-quadrant model coming on. I feel another model coming on. And again, I don't like 4-quadrant models because they're usually too simplistic, but they do help you to get a picture of what is happening out there at the simplest level. And here it is. So I've kind of stolen this idea from Gartner, of course, but what the hell. The two dimensions, I have the ability to capture knowledge running up and the ability to investigate running from left to right. Okay, so you'll see all the tools, and this is not a well-researched, it's not a deeply researched piece of information I'm presenting to you. It's very speculative, but this is what I think is happening out there. We have tools that do, to varying degrees, capture knowledge. We have tools like text editors, note takers, mind maps, pencil and paper I include in there, as well as UML and case tools, as some of you will be well aware of. But they are all to the left. They have an ability to capture knowledge to varying degrees, but they do not think for us. They don't have any ability to investigate. They don't ask questions. They can't make judgments. All they can do is capture the information a human thinks of and hands and transfers to the tool. Look a bit further at this is like in our ability to capture knowledge, the vertical axis, What have we got? Basically text editors and screenshot utilities, pencil and paper, which I think is better than many software tools because they don't limit your imagination. So I'd put them quite high on the kind of the maturity scale, if you like. And of course we have dedicated modeling tools, and these have been around for many years, whether it's flowcharting or entity models or the full range of UML modeling and diagramming capabilities. These have been around for some years. We may be some way up this scale. The most sophisticated tools possibly can do almost everything we want, but these tools do not allow us to use our imagination and to come up with new forms of models, which might be necessary given our task as a software tester, even as a software designer, I should say. On the ability to investigate the horizontal axis, if you like, the lowest capability would be the tester does all the thinking and has complete control of the process. The tool basically captures the thinking. What would the highest capability look like on this scale? Well, the tool is capable of asking its own questions, having its own conversations with end users to get to the bottom of a requirement or anomalies in thinking in the user's heads. It makes its own models. It makes judgments on the relevance, completeness and accuracy of the information it acquires. The tool does all the thinking required. Now we are very far away from that kind of capability. And I've used this phrase, these tools are all bottom feeders in this respect. We're really at ground zero, level zero on this aspect. But this is where I think the tools that need to support testers have to go. Certainly to become bots that replace testers completely. The progress we have to make is on this ability to investigate. So what's my model useful for? I don't want to make too much of it, except and as I've said, all the tools that I can think of, and there's probably a few, and probably many I haven't referenced, they're on the extreme left, mostly towards record keeping, if you like. What's the model useful for? I want to suggest it's not about classification of tools. It's really a hint to tool vendors to say we must start making progress to the right. We must look at technologies that support modeling in a much more familiar, usable way, that are much closer to the investigative, the exploratory way that people think. Last of all, I want to consider the situation from a different perspective, so how testers fit into society almost. I just want to draw a comparison with the medical profession. Now, in the same way as testers, doctors ask questions, look for systems, take measurements, and kind of their diagnosis is similar to a kind of a debugging kind of process in the heads of testers stroke developers. And many ailments, that people suffer from can be identified in minutes, if not a few hours, with the right scanning, measurement, and test, if you like. Now, it's become apparent over the last few years that the procedures, the thinking process that doctors go through in making a diagnosis can be performed by bots. And I've seen reports that actually bots now are more effective and more accurate than actual professional human doctors. The challenge here is that doctors won't be replaced by bots so soon, because at the end of the day, humans like dealing with humans. And I have to also say, certainly in the UK, the doctors are a powerful lobby. They're not going to be replaced by bots in a hurry. Now, although doctors can rely on their lobbying power, I don't think testers can. I don't think testers are immune, if you like, from being the target of computerization, if people believe this is possible. So I think we have to be on the lookout. I don't think we can say our jobs are safe forever and a day. So I want to really look more at the future now and just explore how I think tools will evolve in the next few years. So far, I think the tools that the vendors have produced, although they are fantastically sophisticated, they've really picked the low-hanging fruit. It's what I've called mechanical tools, the tools for test automation, test execution, test running. And that market is kind of crowded. I mean, there are tools for every kind of execution of tests on all platforms now. And open source tools have also made great inroads into this market, which is great for the testing community. We have a choice we never had now, but it's kind of saturated. The unexploited market in tools that support system exploration, collaboration, test design, the thinking of testers is potentially much larger than test execution tools. And if you like, every single tester needs them, whether they automate their tests or not. And so the size of this market is, how many testers are we talking about? I couldn't possibly say. It's 1 million, 2 million, 3, I don't know. It's millions of people who are testers, who are professional testers. But also every developer tests, so they need them too. Many users test, and they may need them too. Business analysts also test, and they need them too. It's a completely wide open spectrum of user communities, all of whom do more or less test thinking, test design, as well as test automation. So I think the market is there. It's crying out for support in areas that in the past have been very badly supported. Looking at from the point of view of employers, there's a great frustration with testers and testing. And you know, the biggest companies that employ the biggest teams of testers, by and large, are very frustrated with testing in that they believe their testers are unimaginative, working by rote, following processes and procedures, generating mountains of paper, but still failing to match the quality or to support the levels of quality that are demanded by banks, governments, and whoever the industry is. So there's constant pressure to cut costs, and that is not ever going to go away. Now, what we also know is that the productivity of exploratory test approaches is proven. Everyone who's ever tried to do some exploratory testing looks back on scripted testing as a slower, plodding way of working. However, we have this notion that exploratory testing is more efficient and effective, but in many contexts, the need for control and documentation constrains the tester. Managers need to see this documentation produced. Stakeholders need to see this documentation produced. Suppliers have to produce documentation for their customers in order to get paid, to demonstrate what they're doing. So my argument with all these pressures is that if testers had tools that can capture the thinking and the models that we create in real time, there would be no need to generate so much documentation, because that would be a byproduct of the thinking and modeling that testers do in every situation. So my suggestion is the next generation of tools could be led by tools that support the exploratory process, the exploratory activity of testers, where testers takes the sources of knowledge, be it people, requirements, the old system, the new system. These sources, what testers do is they explore, they model, they assimilate knowledge, they capture that, and that is the basis of their test design. If we can capture that knowledge in flight, if you like, perhaps the need for high levels of documentation could go away, because it could be generated by a push button. Now, in order to sort of explore this a little bit further, I want to use the metaphor of surveying, like a building surveyor, if you like. So I want to use this concept of system surveying as a way of explaining how the process might evolve. So if we have this idea of we have tools that support our thinking and exploration, and we call it surveying rather than, if you like, test analysis, which is what it might have been called in the past. It's more than test analysis. I think a new style of testing emerges. Our relationship to development shifts somewhat, and it supports the idea of shift left to get closer to developers. But our test documentation is no longer created in like a knowledge vacuum. We don't start blind when we're creating documentation. We can create documentation, or models, I should say, that match precisely the systems that we have available to test. Our knowledge acquisition, just like our end users, our developers, the testers, we build up our knowledge in an iterative or incremental way as we learn how the system should behave, and how we learn how the system actually does behave as features are delivered and tested. So our thought processes are incremental and iterative. The systems we use should account for an incremental and iterative way of thinking and data capture. And only this way could we have what you might call an agile test process. Certainly, if we work this way, it would fit, the changes that are on people's agenda nowadays of continuous delivery, DevOps, and so on. So system surveying, if you like, the vision for a system survey is an exploration of our sources of knowledge. And as we explore, we make a map. We map the territory, we map the architecture, we map the paths that we can take through our system, whether it's from the perspective of a requirement or the actual system under test. So as we map the territory, these are the models that testers produce. In the past, it might be a mental model, never captured, never shared, except verbally. These are the models that provide the maps for other testers to follow. Now, these maps also might be the basis of the developer's design and build activities too. They might actually be completely aligned. Now, this would be fantastic because that's never happened before. Our surveys demonstrate and articulate the changes over time that the learning process of identifying requirements, refining requirements, building the system, evolving the system. Our surveys, our models, reflect the changing level of our knowledge. Now, as part of the exploration process, the paths we take through an architecture represent valid paths through the system itself. So these valid paths provide the basis for our scripts or procedures should we have to produce them. They provide these scripts or procedures for perhaps our test automation. Now, I'm sure you've heard from many of the vendors making the offer of no need for extensive scripting or test procedures or programming capability. But that's based on using some abstract language, but you still have to do that thinking. But I want to suggest that if you capture the knowledge of the system in a model as the thinking takes place, as the exploration takes place, we capture models that have much more meaning, are accurate, and can be reused by other people, other testers, and the developers as well. Now, if the process is this incremental, iterative, so on and so forth, we can separate some sequential activities from some parallel activities. We can begin to shape what our test process should look like. So in sequence, we have quite clearly some form of surveying, some initial evaluation, exploration of sources of knowledge, and the source of knowledge could be users, developers, the system, the old one, or the new one. We create models and we can refine them, and then when we are ready with our models, we believe our models reflect the behavior of the system under test, then we can derive tests from that trusted model. But there are also parallel activities, and we know that small subsets of functionality can be evaluated separately. These processes are both iterative, incremental, as learning proceeds. So what I want to suggest is that we can shape our process on the basis of the information we gather, on the model making and the model refinement that we do over time, on the learning that our whole team, including users, analysts, developers, and testers, the models reflect the state of learning within the team. Now, it's a bold statement, but I want to suggest that if you can survey it, you can test it, you can automate it. So the way I'm thinking about how the process will look is that, if you like, humans make the early maps, perhaps the tools follow the trails we make. It may be other testers follow the trails we make, but I'm thinking that the automation process should be much simplified because we have trustworthy models shared between developers and testers and users and operations and project managers and so on. Now, everything I've said in the last few minutes, I don't think you need machine learning to do it. I don't think you need artificial intelligence to create models as one explores the system under test. So my argument is that the next phase of development of tools could be to do this learning, this modeling on the fly. The tools that follow that have artificial intelligence need data in order to learn how to behave in the future. Well, that data will come from the next generation of tools which capture it in a systematic way. So I'm just going to summarize really. So what effect will machine learning have on testers? Well, I think the tester surveys, the models, are the source of data for bots that will come later. When we model a system, when we log our questions, observations, ideas for testing, our concerns, when we map these to the system model, we can manage our learning process on the basis of a model that is consistent throughout our team. Now, in order for this to work seamlessly, we need formats and protocols for the information we capture, maybe a standard, but I don't want to go down that route just yet. But I do believe that the data we capture in modeling will subsequently be reused by bots that perhaps can support us in a much more systematic and sophisticated way. Right now, I think it's much more likely that developers will be affected by machine learning. What the report I mentioned earlier suggested was it was a 50-50 chance developers will be replaced in the next 20 years. I think that's influenced, perhaps over-influenced, by a dependency on formal methods, which have been really hard to get working. They've been around for 20 years. But I think it's much more likely that developers will be affected by machine learning rather than testers. Testers have to be independent almost of the formalities that developers must follow. So right now, I think from the testing community's point of view, I think we have to wait a bit longer for Terminator Tester. Not yet, is my summary. I think we have some time to wait before we're out of the job. And with that, I'll say thank you very much. And over to you, Dara.
Thank you very much, Paul, for that presentation. And before we have a look at the Q&A, let's just have a look at one or two more slides here. So to begin with, we have another webinar taking place today on test-driven development for the rest of us with Gil Zilberfeld. And we have another webinar this week with Michael Bolton that will be exploring test cases. And to register for those, just head over to the Huddle website. We have other webinars coming up over the coming months that look at agile leadership and maintaining quality as well as Java memory. And all the information regarding these webinars are on the Huddle site. This week is a very big week for us here at EuroSTAR, as our program will be announced tomorrow. So you have there's an option to purchase tickets up until midnight tomorrow night for 20% off. So make sure you head over to the EuroSTAR site to find out a little bit more about that. And if you can't wait until November to head to EuroSTAR conference, we have another brand new event taking place in Oslo on May 11th called EuroSTAR. It's a one-day testing event, and the link there to find out more about this conference is a eurostarsoftwaretesting.com/EuroSTAR. So let's take a look at some of your questions here. To begin, Paul, someone mentioned here that robots must capture information first. Why can't we make faster progress on ability to investigate capability?
I think that, and one of the things I was talking about just towards the end of the talk was that the tools we need next are tools which will capture information on the models we create for our systems. Now, in order for the bots to take control over what testers actually do, they need a bank of data in order to learn how systems should and should not behave. They need both the models, they need the mechanisms for traversing those models, and some information how they make choices of whether a path and an outcome of a test is a success or a fail, for example, to put it simplistically. So the models, the bots that do software testing that will replace testers must have this process of learning. They must have a bank of knowledge. Now that cannot just be created from scratch. It has to be captured by people who are making these models work, who are capturing these models. So I think you won't see many applications of bots in the testing space until there is a database of examples of successfully working and unsuccessfully working software and systems that have an underpinning model that allows the bots to navigate through it. I have a friend who's working on a bot to do, the reason I say this is I have a friend who's working on a bot to do image-based mechanical test automation. That is, if you like, a bot with a camera, an eye, image recognition, and a mechanical way of pressing buttons and making slides and gestures on a phone or a mobile device. And his argument is, well, my bot won't be successful until your bot, what I'm making, can capture the data that it can learn from and implement its own thinking, if you like. Up to now, even a bot that can do image recognition, whatever, is still completely dependent on a tester writing code, preparing expected results, and so on. It's only when that coding and the expected result generation can be done by a bot, can the bots that use image recognition and then a mechanical technique for running tests, you can't have one without the other, I think. You can't do it in one step. I think there has to be almost a heritage of using bots that capture models in a more sophisticated way. You have to have that almost heritage before you can complete the journey towards bots that are completely independent. Now that next step might take 5 years, it might take 50 years, I have no idea. But I don't think you can avoid that step. I think that's where I'm coming from.
Do you think AI-driven test design exclusion tool is a feasibility once scriptless automation becomes reality in an AI world? If you want me to repeat that, I can.
It's okay. I think there's two things. I think there's two things going on there. I mean, the first one is, could test design be automated? Absolutely. That's what model-based testing is. But the problem with model-based testing is as a brand, and I'm going to call it that for just a second, model-based testing is based on formally designed models. That is, you capture your model in code, and then a robot or some software comes along and reads that code and can generate boundary values, state transitions, decision combinations, and so on and so forth. What you haven't done is replace the thinking to create that initial model. So we are already perfectly capable of creating codified requirements, codified designs, which a robot can come and generate test cases from. But ultimately, you're not testing the requirement. You're not testing the thinking that a user has put into creating the model. You're just testing that model. If that model is wrong, the system is wrong, and the bot will never discover that. So in that respect, we are already there. You know, what we have made little progress on is a mechanism for creating meaningful models that allow a bot that has the intent of testing to take and generate and execute tests. So I think that's where we're at, in that, if you like, we can abstract right back to the very beginning to a mathematical language, but then you still have this problem of how that mathematical language can be used to validate the thinking of the users in the first place. And that is a human relationship, I think. We haven't made much progress on that yet.
Early on, you mentioned Dan Dare. In Dan Dare, Prisoners of Space, there's a mention of trusting an AI to pilot a ship and the hesitance to do so. Do you think there will come a point where testers move from testing end software to testing AI tools that trust the software? i.e. to build
Yeah.
trust in the AI tools?
It's a bit of a philosophical question. I mean, the interesting thing about, I only mentioned Den there. I'm not a particularly fan of it. I just happen to recall, reading about it one time, a long time ago. We have robots which can pilot planes to take off and land. We almost don't need pilots anymore. We have pilots because it's very unlikely that anyone would pay to fly on a plane that was completely automated. But that day will come, just like driverless cars will come. Now, how do you test the tools that perform those activities of automatic takeoff and landing, testing and evaluation and decision making and judgment and so on and so forth? I don't think we have any other mechanism than by throwing endless examples at these tools, and they learn through example in the first place. So if you like, when we throw 100,000 examples of the tool, and the tool then has this knowledge, if you like, this knowledge that it's gained from the examples that you've given it, you could then say, okay, it now knows enough to make sensible choices. But there's no guarantee of that. So how do you test that? Well, you can't test that except by finding more examples to throw at it and seeing how it behaves. So it's not an example where it gets the answer, if you like. So tests are simply more examples. So the way that we will test, and this is a kind of a trivial example, but a very serious one in some ways, the way we test driverless cars is by putting them in more and more stressful, if you like, situations to see how they react. And it's only by putting them in stressful situations will they learn how to react in those stressful situations. So the challenge of testing is to find more and more imaginative ways to break our bots, to make them make bad decisions, to make them contradict themselves, make mistakes, and all that good stuff. So the challenge of test design is unchanged. We still have to find more and more sophisticated scenarios, test cases, call them what you like, in order to challenge our bots. It's just the same as testing any other piece of software. We just need to have more imagination than the bot does and the system does in order to break it. I don't know if that answers it or not, but I think that's how I'm thinking.
Another attendee here is asking if you have an example of a model.
They're all around us. You have them in your heads endlessly. We simplify our perspective of the world by building mental models. When I talk through the new model testing idea, I talk about how a human being manages to walk from A to B and lift a glass of water and have a drink without dribbling. In order to understand the complexity of the 100 muscles in our body that control movement, we have to build a mental model because our brain is simply not man enough to process all the data that's being collected. We have to build a fantastically sophisticated mental model, and in that way we can control all our bodily movements and a lot more besides. The fastest computers of the world are required to do the most simple things with robots that you're seeing, and they are really making progress in that respect. But the way a human works, in order to walk from A to B without falling over, we build mental models and we use those to allow us to control our bodies to make movement smooth and safe. In terms of models, where are they? Well, all the models that you might already be familiar with, a definition of a domain for boundary values or equivalence partitioning, these are models. A decision table is a model. A state transition model, a state table is a model. A risk register is a model. A checklist is a model. Anything you scribble on a whiteboard that helps you think about how you understand complexity, how you understand the system, how you understand the behavior of a system and how you might test, these are all models. Models are absolutely everywhere. And it's like the air you breathe. If you're a tester, you are constantly modeling. That's just the way it is. Most of the time, you don't write these things down. But remarkably, in your brain, these models are created, evolved, calibrated, recalculated endlessly. And that's what we do as a human being. It's a perfectly natural thing for us to model our way out of a testing problem. That's what we do as testers.
Another attendee here is asking if they can get an example of surveyor in testing.
I wish I could say I could point you at a website that will work. I've created an early partial prototype, let's call it that. And I was working on it until just before Christmas, and then I moved house and I got taken up by some client work. So I kind of shelved it, and I'll be working on it again, I think, from next week. So I think watch this space. I'll certainly be making noises and asking people to take a look at what I've got, and certainly some of the ideas I've got and some of the experiences I've got. I've written a couple of articles, I think, in Professional Tester, if I can say that. Is that right, Professional Tester? Good heavens. I'll have to confirm that. I've written some articles recently which will be published fairly soon that give out some experience of what I've been doing and what I've been learning. But watch this space. There's more to come.
I think we're almost out of time here, so I think we might just wrap up there and say thank you very much to today's presenter, Paul, for taking time out today and talk to us about robots. And we really appreciate it. And a lot of you have been asking if this webinar has been recorded, and the answer is yes. We record all of our webinars, and I will send you all a copy or a link to the resource page where you can view the webinar and slides, and that'll be sent out to you in roughly an hour's time from now. So thank you for attending, and if you want to attend any more of the upcoming webinars, then just head over to the Huddle site and you can register there. So thank you all and take care.